Hello, everyone, and welcome to another episode of Red Hat Czech Talks Tech. My name is Dorka Valkova, and I'll be again helping with moderating today. So today's episode is going to be focused on continuous integration tools. But before we start, let me share some general notes. So in case you have any questions, do not hesitate to ask and use our Q&A tab. We will either reply during the session, or if it's like a more complex question, we can talk about it after we finish. If there are any issues with audio or video, let us know in chat. And in case you'll want to share this with your friend or rewatch the talk that is coming, we are recording it and we will publish it on our YouTube channel in a few days. So that's it for the general notes, and let's go directly to what all of you come for, our talk. Let me introduce our two speakers, my two colleagues, both senior quality engineers at Red Hat, Jakub Stejskal and David Cornell. They prepared a talk about continuous integration tooling. They'll start with the short introduction into the topic, and then they prepared several demos for you. I think that's it for introduction. Let's just dive right into it. Jakub, David, go ahead.
Okay, thank you. So, hello everyone, my name is Jakub Stejskal. I'm working as a senior software quality engineer at Red Hat. I started Red Hat 4 years ago as an intern, and now I am one of the maintainers of Streams project, and I'm a tech lead in IMQ Streams QE team. Over to David.
Okay, thank you. So hi all, my name is David Cornell, and I work as senior software quality engineer at Red Hat. I joined Red Hat 5 years ago as an associate quality engineer, and during my Red Hat journey, I was working on several projects like MQ Broker, MQ Clients, and Messaging as a Service, where I was also a QE tech lead. Now I work on different project, which is a managed services on Kubernetes. My previous job was an automation engineer slash system admin in company focusing mainly on Microsoft technologies. So it was challenged for me to move from ecosystem to an open source project and start working with community around the world, but I really enjoyed. So that's all about me, and let's go to the next slide, please. So what is the agenda of today's talk? We will really briefly describe what is a CI and core components. Then we will show you most used CI systems, and then we will present you flow from the new pull request to production ready artifacts. And then on the end, we prepared some free demos about Github Actions, Azure Pipelines, and Jenkins. So let's move on. Next slide, please. Yeah. So what is a CI? You can find on the internet many definitions, so I picked this one. CI is a practice of automating the integration of code changes from multiple contributors into a single software project. Basically, it is a collection of tools which helps you to work on the software code with multiple contributors and also continuously test it. CI system has 3 core components. The first one is a SCM, which is a source control manager, which allows you to maintain code base, create a pull request, rollback the changes, and so on. You can use your own Git server on premise or some Git clouds like a GitHub, GitLab, Team Foundation server, and so on. Then you also need to have it an automation platform for executing your pipelines and scripts and so on. Basically, this is the heart of CI system. You can use some on-premise solution like a Jenkins, or use a cloud CI systems like a Github Actions, Azure Pipelines, Travis, and so on. And the last, what you really need for CI is an infrastructure. You can have it your own bare metal servers or static VMs, or use some cloud provider for infrastructure as a service like AWS, OpenStack. Some of automation platform provides also this infrastructure as a service. For example, Github Actions also provision container for running your tests, so you don't need to care about it. Typical use cases of CI in our daily work are building artifacts, running tests, releases into the public registry, and so on. And that's all. And I would like to hand over to Jakub, who will talk about CI providers which we use and about pull request flow. You are mute, Jakub.
Sorry. Okay, let's talk a little bit about Jenkins and other CI tools. Jenkins is a community project. It's a CI tool which is basically self-managed, so you need some server where the instance of Jenkins will be running. The great thing on Jenkins is that, as I mentioned, it's a community tool, so the community around is very huge, and there is a lot of plugins which basically improves the usage of Jenkins, and you can basically change the behavior of it and improve it for your own usage. The example of these plugins are, for example, JMS, which is very useful for sending events from one pipeline to another, or, for example, OpenStack plugin, Kubernetes, XUnit, and lots of more. The pipelines in Jenkins are written in Groovy, which allows you to write more complex code in it, but it's also harder to debug because Jenkins Groovy is not the same Groovy as you are used to use in classic code. It's a little bit complicated there. Another CI tool which we use very often is GitHub Actions. GitHub Actions is a system hosted by GitHub, so you don't need to care about agents which will be provided for your pipelines. Everything is hosted by GitHub. GitHub Actions allow you to do cool integration into GitHub repositories, so it's very easy to create any workflow there and run pipelines for each your PR or just simple commit into the branches. David will show you during his demo. The great thing on GitHub Actions is that it allows you to have 20 concurrent builds, which is a great number. Even if you have free tier, which is great. Next tool is Azure Pipelines. It's very similar to GitHub Actions, but the main difference is that it's not hosted by GitHub, but it's hosted by Microsoft. The integration with GitHub repos is very similar. You can very easily create and commit pipelines into a repository and basically run them with every push or PR. It's basically up to you. I will show you during a demo as well. Another point is the Azure pipelines allow you to run 10 concurrent builds, which is a little bit lower number than GitHub Actions allow you, but still it's a pretty good number. Next CI tool is Pro. Pro is a Kubernetes-based CI/CD system. It's another community tool, so you basically need to have some Kubernetes cluster up and running, and you can install it there. The great thing on Pro is that it also offers great GitHub bots. So you just can chat basically with the bots with comments in your PR, and the bots will do the work you will need. For example, merging the PR, running the test, and so on. Pro is widely used by CNCF, which offers it to CNCF projects like Kubernetes, for example. And it's also used by OpenShift CI. Next two CI tools I want to mention are CircleCI and Travis. I just wanted to mention them because there are some limitations which are pretty annoying from my point of view. The first one is that CircleCI and Travis allow you really low number of concurrent builds. I think it's only one for CircleCI and 5 for Travis. And there's also a limitation in time per each build, which is set for 60 minutes, and it cannot be changed. On the other hand, Azure Pipelines and GitHub Actions allow you to run each pipeline up to 6 hours. Okay, that's all about most used CI tools. So next slide, please. Thanks. Here's a simple workflow, which we basically use in our projects. At first, there is some user. You can imagine that basically you will create some PR and push it, for example, in GitHub, or you will push the code and create PR. And at this point, the phase one will start. In this example, phase one means that Azure Pipelines will set up some job and it will build the project and run the unit tests. In case the phase one will fail, which means that the jobs will not finish successfully, the checks on PR will be set to fail, and user have to do some manual changes to code to make the pipelines working. But you always want to have first phase green. At that point, the phase two will start, which means that GitHub Actions will be started. Here we use, for example, pipelines for build documentation and put it into stage, which allow the users to see the documentation wasn't broken by some changes. Another point in phase two is Jenkins, which could be, for example, used for building images and run end-to-end tests. When the phase two will finished, the checks in PR will be set to green to passed, and now there's this part when you should ask your colleagues from the project to go through the code and do a review of it and approve the PR. So when your PR is approved and all checks are green, it's time to merge the PR into the main branch or into master. It's up to you. You can use some bot for that, or you can do it manually. It's basically up to you and your integration. And when the PR is merged into master, there is a last phase. We call it phase 3. During phase 3, we basically build the project, run unit tests, build the images, and push them into production, for example, into Ui IO registry, and build and push the documentation into production as well. This workflow is very simple, but we basically use it in streams and in mass. And in case you will have more complex projects, I can imagine that the workflow will be very similar, but there will be probably more checks and phases. Okay, that's all about the slide. And over back to David. He prepared a demo about GitHub Actions.
Okay, so let me share my screen. Can you see my screen?
Yes, we can.
Thank you. Well, welcome to the first demo. It's about GitHub Actions, and I will show you how easy it is to set up your first workflow for your own repository. With Jakub, we prepared some basic demo Quarkus application, and we also wrote some unit tests. And right now, I will show you how to set up the GitHub Actions from the web UI. Basically, we just opened the repository, and here is a new tab which is called Actions, and we can create a new workflow. Because the GitHub knows the code base of your repository, and it detects that the code base is written in Java, it offers us some predefined templates, or we can just start from scratch. But I will show you how to start from the template, and we will take the template for the Maven. You can see that the Github Actions is defined in the YAML format, and every workflow is stored in .github workflows folder as a YAML file. So we can just create a new one, which is called example. We can rewrite the name of the workflow. And one of the big advantages of GitHub Actions is a large community around, and you don't need to care about setup of Java, Maven, and other tools which you need for the build and testing on the container. And you can just reuse already created, like for the setup of Java. We know we need Java 11 for our project, so we can change the version here. And there is the CI events are defined, and we will see that this action will be triggered by every push to the main branch and on every pull request against the main branch. So let's create a commit as a new PR. And create a pull request. The pull request is created, and right now we are waiting for the GitHub Actions to be triggered. You can see that example pipeline was scheduled. You can see the details. And right now we are waiting for the new container for the running our build and test. So yeah, the JDK 11 is set up. And right now we will see a lot of download status because the Quarkus application depends on many packages. So basically the build is in progress. And right now the tests were executed. And that's it. If I open the PR again, I can see that the example pipeline was successful. And right now we just enabled the first pipeline for our repo. So that's it from me, and I'll hand over back to you.
Okay, so let me share my screen. Okay, can you see GitHub repository?
Yes, we can.
Okay, great. So to set up Azure Pipelines against your GitHub repository, you need at first to install Azure Pipelines application. You can do it via Marketplace. Just simply open it, type Azure Pipelines, and then hit install button, and it will be installed in your profile or in your organization. The second thing that you need is Microsoft account on dev.azure.com. When you will have the account, you will see something very similar like this. At this point, you need a new organization. So you just need to hit a new organization button and fill the form, which basically needs some name of the organization description. And then you need the project inside it. I already have an organization, and I also created a project, so I will use already created one. So let's open it, and let's move into pipeline section. I already prepared two pipelines. The first one is simple hello world pipeline, which basically prints something into the log, and the second one is for building the project and run the tests. I can show you how to create a completely new pipeline. It's very similar to GitHub Actions. You just need to hit the new pipeline button, pick where is your code, it's GitHub for this case, Here you will need to set up a repository which you want to use for a pipeline. So let's pick the one which we prepared, and then just pick how you want to configure a pipeline. So you can use Docker, you can use deployment to Kubernetes, or just start a new pipeline, or use already existing one. Let's pick a start pipeline, and Azure will generate something like this for you. It's not so smart as GitHub Actions, because this template is basically for all projects, so it will not generate the template based on your code. But still, it's pretty simple. You can change there the triggers, steps, tasks. It's up to you, and then just hit the save and run button. And based on your trigger configuration, it will be usable as the GitHub Actions, which David showed you. Okay, let's get back to my two pipelines which I prepared. Let's open the Hello World pipeline. It's very similar to the template which I showed you just now. I only changed the trigger part there. The trigger here is set up to run continuously against main and release branches, and also against every tag. And I also set up a trigger for PRs, which basically means that when you open a PR, this pipeline will be triggered as well. In case there is already build running of this pipeline against some PR and you will commit new changes, the pipeline will be stopped and you will be started. Okay, that's everything about Hello World pipeline, and let's just run it. You can pick there a branch which you want to execute in, or even the commit. Just simply hit the run button and it will be queued and it will execute it. Meanwhile, let's check the Android pipeline. I removed there a trigger based on the CI, but I set there a trigger which basically checks that Hello World pipeline is already finished, and if yes, this pipeline will be executed right after that against every branch. Another change here is that I'm going to set up OpenJDK, which we need for a project. I do it in a bash task, but you can even use some already pre-configured tasks, which is created by community, and it's very similar to GitHub workflows. You can see that I use Maven task here. You just need to put there some configuration, and it will be basically the same as Maven command in Bash. There is a lot of tasks which are already available, so you just need to go through the documentation and find which you want, or you can create a new one and push it into GitHub, and it will be eventually merged into Azure pipelines. Okay, let's get back. We can see that Hello World pipeline succeeded. It's great, and the build pipeline was triggered again against main branch as well. We use Azure pipelines in Stringy project, and we basically use also comment triggers on GitHub, which looks like that. You just need to type -acp run and name of the pipeline, and the pipeline will be executed. And into checks of the PR, the results will be added. Okay, let's check the pipeline. Yeah, we can see that it's building the project, and I think it will succeed, which is good. You can also see the results in PR which David created a few minutes ago. It's very similar to checks from GitHub Actions. there's a name of the pipeline and the result. Okay, that's all from me, and hand over back to David, and here's another demo.
Okay, let me share my screen again.
It's working.
Okay. Yeah, thank you. So the last demo is about the Jenkins. It's about our production Jenkins, which we use every day for the building artifacts and testing. As Jakub already mentioned, the Jenkins is a different declaration. It used Groovy, and on this file, you can see the definition of the job. And on the end of this definition is a link to the pipeline, which is the pipeline itself. So it contains the steps and all the execution which we need. What is interesting on this definition of the job is that this job is triggered by the UMB event. UMB is a unified messaging bus, and it is a bus for sending and receiving the AMQP messages, and it's for exchanges the data and events between the building systems and the Jenkinses and other systems. And this job is subscribed to the CVP pipeline, which is the pipeline which is triggered by the Red Hat build system in case where Red Hat needs to build and push out the rebuilded images with some CVE fixes and security issues and so on. Security issue fixes. Yeah. And let's check the pipeline itself. It's written as a declarative pipeline. And on the beginning, you can see that the agent, which is the virtual machine, our Jenkins is connected into the OpenStack. So the OpenStack will provide the VM which we need for the running the test. There is some stages for the check bundle and other which we need, and there is another waiting for another UMB message with some index image which we need for the testing the OLM for our operators. And there is triggering another job, and this job is for the testing. So let's see how it works in this video. So this is the Jenkins UI, and you can see that we have two jobs. The first is a trigger, which is triggered by UMB, and the second one is for the running the test. And right now we are waiting for the UMB message. The UMB message should be sent, and job is triggered. So we can check the console output, and we will see that the job is waiting for the node from the OpenStack. So we can check the parameters of the job, and you can see the CI message, which is the message from the UMB, and this message contains some important information for us for the running the test, like a destination of the images and so on. So let's move on. Our job is running because it received the VMs from the OpenStack, and right now the stages for the image check and so on are running, and we also received the message with the index, and right now it triggered the testing job. The testing job also needs another VM for the running. It is a different VM from the previous job, and there you can see the parameters from the messages, like index image, destination, and so on. The job received the VM, and it's running, so we can skip it. And right now the test is running. Tests are written in Maven, and right now it tries to deploy the MQ streams operator on the cluster, and so on. So we can skip the test part. Test is done. Tests are done. It will also send the data into the report portal where we store the results, and we can see the job is successful. And trigger job was notified that the job with test was successful, and right now it's sending the messages back into the UMB and other systems for the releasing. The images are notified that these images are ready to be pushed into the production, and it will take care about the pushing. And that's it. So I'll hand over back to Jakub.
Okay, thanks. Slide, please. Okay, so let's do a little bit summary about the presentation. So the first point which we want to tell you is that you should automate as much as you can and use the CI tools which are available for you. It will be much easier for you if you will set up some simple pipelines in Azure, GitHub, whatever, and you will test your code with every push into the branches. It will basically save you a lot of time with potential issues. Another point is that manual steps make sense, but you need to have proper case for it. The first one is, for example, exploratory testing, where the user should or the tester should come with some fresh idea, and in case you're testing some big project, for example, you will hit some issues with some very strange configuration, which is not easy to automate, for example, or it's too complex to automate, for example. That's basically the second point here. If the automation is too complex, it makes sense that you will do the verification manually. For example, if you will have very simple UI page with some login screen, for example, just only this one, it will be very time consuming to set up some tests which will only check that the login screen looks fine. So you can basically just start the program and check it manually in 1 minute instead of writing some automation. I already mentioned the third point, so let's talk a little bit about the last one. Basically, if you need to combine multiple CI tools which are available, you don't be afraid to do that. It's very simple, as we showed you, to set up Github Actions and Azure pipelines as well. The Travis, for example, is simple as well. There are some limitations, but in case that concurrent builds on GitHub and Azure are already fulfilled by you, you can use Travis as well. And in every CI, you can do a little bit different steps, like use GitHub Actions for building the project and run the tests, and use GitHub or Azure for building the documentation and pushing it somewhere. It will save you some time as well, instead of waiting until the old jobs will be finished. And that's basically it. Okay, that's all from me and for David. I hope you enjoyed the presentation, and that's all. And thank you for your attention, and enjoy the rest of the day.
Thank you very much for the summary and for the whole talk. It was awesome, and I enjoyed it, and I hope others enjoyed it as well. So this is your last chance to ask any follow-up questions. I'll share other information with you in the meantime, but don't hesitate to ask in the Q&A tab, and our speakers can still reply if there is anything you would like to know or didn't understand. So if you're interested in these topics, definitely check out our huge annual community open source conference called DevConf CZ. Let me share a link to our website with you. The registration is open right now. It's going to be virtual for the first time for us and for attendees as well. We have a packed schedule with many talks, workshops, meetups, discussions, and fun activities. Definitely check that out, and I hope we'll see each other there. So let me just remind you that this session is being recorded, and you will have a chance to watch it again or share it with a friend when we publish it on our YouTube channel in a few days, hopefully. And then we are really trying to make this event as great as it could be, and we need your help. Please share your feedback with us and let us improve. I'm going to put the feedback link into the chat. We will also follow up in email and ask you again, but as soon as possible would be nice because you still remember what worked well and what didn't for you. Okay, do we have any new questions? I don't think we do. Then it's time to say goodbye. And again, thank you for attending, participating, and listening to what we prepared for you. Stay tuned for our next events. And have a great day and stay safe. Goodbye.